4.2 is on limits and continuity. So first, let's look at the definition of limit again. I'm not going to review past stuff. It'll look very familiar, and we'll describe it a little bit, and then go on to basically taking limits as we did back in Calc 1, or you may have done in Calc 1. Okay, so this is the definition of a limit in two variables. And you'll see once I define this, you can extend this to three or more pretty easily. So if I say the limit of f of x, y, and then you need space right here when you write these, as x, y approaches, and we'll say x naught, y naught, equals L. Okay, so that's almost the same as before, but now you're going to x naught, y naught. Means that given any epsilon greater than 0, there exists a delta greater than 0 such that 0 less than, and this is normally when you would say absolute value, but now you're doing distance, the square root of x minus x naught squared plus y minus y naught squared less than delta, less than delta implies absolute value of f of xy minus L is less than epsilon. So this is basically a delta neighborhood. So if the delta neighborhood is small enough, basically around x naught, y naught, then that implies that the function value is different, the function and its difference is as small as you ever want to be. So what you have then is this delta neighborhood in the xy plane that would look something like this. And so you basically are like squeezing in on the point, the delta neighborhood. Okay, so you're coming in like this. So there's your delta neighborhood around that point. Doesn't look good, does it? There we go. And so this is your x naught, y naught. So right there would be your x naught and y naught. So you can get as close as you want to the limit value by basically making this delta as small as it needs to be. If you can do that, right, so you can basically make that larger or smaller, you can shrink in on it as however size you want, like that. And that's what you need to do. So that's a delta neighborhood. Okay, so that's radius delta. Is basically what you're doing. And then that implies over here, this is your z-axis. Here's your L, and then you are approaching this thing or getting close to this thing, this L. So this is your L plus delta, L plus epsilon, L minus epsilon. And then your function values in here, this is your f of xy. So you're not ever in this definition equaling L, but the closer and closer you get within your x naught, the closer and closer this gets to L. So this value keeps shrinking closer and closer within that epsilon. It's virtually the same argument as Calc 1, but you were on an open interval that you were squeezing in on a value. So I'm going to show you the epsilon delta proof, but I'm not going to require you to do it. So this is the delta epsilon proof. So this one says show that the limit of x squared minus y squared over the square root of x squared plus y squared as xy approaches 0, 0 equals 0. Now this one's actually saying to go ahead and show that. Sometimes they just say, is it true or not? So this one, if you just substitute in the values x is 0, y is 0, you get 0 over 0, which is, of course, we know is that's indeterminate. So we don't know. So basically, the question is, does this basically get smaller faster than the denominator? If that's true, then it approaches 0. So it's one of those weird things. So here's what the proof may look like. Proof, you say proof. And the first thing you want is epsilon to be arbitrary. So you say let epsilon be greater than 0. And then we want to show that. Now, what you do next is you would choose your delta. Choose delta to equal, and then I'm going to erase that. I don't know what it is yet. So then you do your research. I'll do it over here. And I kind of know what it looks like, so I'm going to box it in ahead of time. Okay, but you wouldn't necessarily know. So you do your, this is scratch work, but we call it research because we're in Calc 3. I say that for Calc 1 too, but whatever. So what we're looking at is absolute value of f of x, y minus L. And then I need to figure out what this may look like. So I go ahead and put in my absolute value of x squared minus y squared over the square root of x squared plus y squared. And now we normally minus L, but there, L is just 0. So it's that. So what I am looking at is some sort of way to analyze it. And one thing I came up with at some point is this. If you look at, well, what we want, or we have, let's say, so we have control over the the square root. So we have control over the 0 less than the square root of x squared minus y squared. Because that is your limiting value, right? It's that delta neighborhood. We have control over this. So, but my x naught is 0, my y naught is 0. So it's just the square root of x squared y squared. So that is less than my delta. But check this out. What I also know is, oh, and that's a plus in there. Okay, so that's my whole point. Well, let me just show you. Okay, so when I worked this out years ago, I don't know right away what it was going to look like, but I knew that that's what I was heading for. So, but I have x squared minus y squared. So maybe, is this true? If I say x squared minus y squared, is that less than or equal to x squared plus y squared? Of course it is. That's a true statement, so we can say that. So then I can say that this is less than or equal to x squared plus y squared in absolute value all over that square root of x squared plus y squared. And then that's actually equal to, so rationalize that and see what you get. You're going to get the square root of x squared plus y squared. And then I can say that's less than delta, which is epsilon. So I'm going to choose delta to be epsilon. Choose delta to equal epsilon. Okay, and then I went, then since, so I stated this in the proof itself, since I have x squared minus y squared less than or equal to x squared plus y squared, we have the following, basically what I wrote down there. So we have all of that. So the implication will hold right in here. You have f of xy less than L. L will be 0, of course, which is equal to absolute value x squared minus y squared over the square root of x squared plus y squared. So that's less than or equal to x squared plus y squared. So I'm saying basically here, since this is true, we have this inequality. So it's x squared plus y squared. So that's in absolute values, like that. And then you rationalize that. So if you check that out, if you do the root, I'll erase this, but if you do, well, I'll just use this. So if you do the root of x squared plus y squared, and you'll see that this is the radicand, which reduces that. So you're left with just that. So that's equal to the square root of x squared plus y squared, which is less than delta. That's what is assumed. Okay, and I needed to say that actually somewhere. So this needed to be stated here. We'll just pull it up there. Copy that. Paste that up here. Oops, not all that. That's not what I wanted. We'll put it here, which equals epsilon. And then you could do the other, you can do the whenever. You can say whenever that's true. So I usually like to write the implication the other way around, but that's okay. Okay. So also, just an FYI, well, not an FYI, I'm telling you, we're not going to be doing epsilon delta proofs. So no epsilon delta proofs required. So, if you happen to want to take a look at some time, look at them, that's okay, but you don't need to. Okay, so